Alright, the last question we're going to do is number 40, which is my function. Let's call it f x to the 5 over 3 minus 5x to the 2/3. So I'll call this function type fraction powers of x. So aside from the fraction aspect, it looks very polynomial-like, but we'll see it makes a big difference. I can, however, say what the y-intercept is. When I plug in x equal to 0, I get y equal to 0. Now, by identifying what the function type is, I do recognize that, when I get to asymptotic behavior, it actually has a lot of similarities with polynomials, in that for these positive powers of x, I have to answer the question if x goes to infinity, approaches infinity, then my function is going to behave like its leading term. I say that when I have all positive powers of x, of course. Now its leading term is this guy, so that's the only one I need to look at. Now remember, I can rewrite this as x to the power of 5, the cube root, minus 5 times x squared, the cube root. Maybe that cube is not very clear. There we go. So, x to the 5 gets bigger when x gets bigger, positive. Cube root of a big positive number, big positive. But if x that was supposed to be an arrow. When x approaches negative infinity, then it still behaves like its leading term, a large negative number, and x to the 5 will also be large negative. Cube root of a large negative number, large negative. Regardless, I have no horizontal asymptote. I also have no vertical asymptote. Because of the cube root and the positive powers, it's defined. F is defined for all x values. So there can't be any vertical asymptotes. So I do have some information. Let's start a graph and feel good about putting stuff on it. Let's make our axes over here. We have a y-intercept, and we said it's going up to the far right, and far left it's going to go down. Alright, that's something. Next, we want to see where is the function increasing and where is it decreasing, and how does it behave. For that, we need to find the derivative. Now, that's not a very complicated derivative to find, just the power rule based properties. So it's 5 over 3 x to the 2/3 minus, let's leave the 5 out. 2/3 go in front, x to the negative 1/3. Now, I have to clean this up. So, these two together become 10. I can take out a 5 over 3. And let's just do that first. I'm left with x to the 2/3 minus 2x to the negative 1/3. Don't try and do too much at once if you're not comfortable with it. Now, a good rule of thumb here is to take out the smallest or most negative power of x, which in this case is going to be x to the negative 1/3. Then I'm left with x minus 2. And it just makes that bracket as nice as possible. If I clean this up, I get 5 over 3, x minus 2, all over x to the 1/3. Now, we want to see, I'll do it up here. When is the derivative equal to 0? And that's the benefit of writing it in this simple, nice form. I can just see it's x equal to 2. When is the derivative undefined? I can just see it's x equal to 0. So having done some cleanup work, I now reap the benefits. So I have two potential critical points. Let's make a table and see how they interact. Whether it's an actual critical point or not, it goes in my table. They are equally important for me in where the function could change from bending up to bending down. So I list all my pieces here. X to the 1/3 is another piece. Together, they give me the first derivative. And I have these sections that I need to identify. Is the derivative positive or negative? Well, 5 over 3 is always positive. X minus 2 is 0 when x is 2. It's in the numerator. Here's my derivative. It's in the numerator, so it'll make the derivative 0. It's going to go negative, negative to positive. X to the 1/3, or the cube root of x. That is an ugly root. Wow. Is going to be 0 when x is 0. It's in the denominator, so it makes the function undefined. It's going to go negative to positive as well. So I have two negatives, one negative, and no negatives. So if I now look at my slope lines, I'm going up, bad things are happening, down. I'm going down, horizontal tangent, up. So I have my cup shape here, but who knows what's happening there on the first one. Regardless, I can write my sentences. I'll do it over here. F is increasing on negative infinity to 0. Should I include 0? Yes, I should, because this is referring to the original function. Original function is perfectly happy with 0. Also on 2 to infinity. Should I include 2? Yes, I should. F is decreasing on 0 to 2. Include them both, because the function is defined everywhere. Just because the derivative is undefined doesn't mean anything. For this sentence, I'm looking at the function. Are these critical points? Critical points. The requirement is critical comes out of this derivative check. Points, function has to be defined there. So yes, they are. 0, 0, we've already found was our y-intercept, right? So here, y equals 0. When x is equal to 2, what is y equal to? Well, I go up, 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 and I plug it in. Use whichever version you want. I like the root version for calculations. when x is equal to 2. So let's go slow and do it. Cube root, I need to look, where are my cube roots? Cube root of 2 to the 5th power, which is 32, minus 5 times cube root of x squared, which is 2 squared, which is 4. Negative 4.7622. Negative 4.7622. So let's put these critical points on a graph. 0, 0. And what happens there? I don't really know right now. And 2, negative 4 point, what did we say? 7622. Lost my mouse. There it is. 7622. Right there, I'm going to have a little cup. Here, I'm not sure. Well, I mean, I am, but at this stage you might not be sure. I am, however, going to be increasing up to the 0 point, decreasing down, and then up again. I think we should maybe try and figure out what's happening at 0. Well, I know my function's defined there. I have a point, I have a critical point, everything is okay. But when I look at the tangent line, slopes, in other words, the derivative, it's undefined. What happens to this function, this derivative function, when x gets close to 0? The numerator isn't getting close to 0. It's getting close to like negative 10 over 3. The denominator only is shrinking down, and the result is the whole thing is going to blow up. So I'm going to have a vertical tangent line. Vertical tangent line at x equal to 0. So I'm write a little thick line there to remind. Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.